Hello everyone, myself Maruthi, welcoming you all to this math video session. In this video, I am going to explain regarding trigonometry sum, and the concept what I have chosen is simplify, right? So it's a little bit a hotcake problem. It is something like different type of model. Let me come back to you. So let me tell you what's the meaning of simplify. What's the meaning of that? So if you know what's the meaning of that, then you can work on that. Simplify means, in my own knowledge or a logical way of thinking, is making as small as possible. As small as possible. This is the tricky word what you have to remember. So what he says, simplify means making as small as possible. Now start thinking on that. In the question, 1, 2, 3, three parts are there. So secant theta, 1 minus sine theta, secant theta plus tan theta. There are three parts. Make the bigger one, make as small as possible. Cool. Right, now I will tell one more logic. Right, you have to remember, numbers are the smallest. Right, remember, when we are thinking to make as small as possible, please remember, generally we get numbers as the smallest. Instead of means trigonometry can be converted as numbers. Come on, man. How can be trigonometry converted as numbers? Means using the identities. Using identities. Right? We are having many identities. We are having square identities. Yes. Square identities we have quotient identities and the next one multiplicative identities what we have. These are the three identities what we have in trigonometry. So that not only there are many more, but generally these are the identities what we have, which converts using identities. Numbers are the smallest. Using identities we can convert right trig as numbers. You have to remember this one. We can convert the trigonometry into numbers using the identities. What are these identities? As you all know, sine square theta plus cos square theta is equal to 1. That is the first square identity. Secant square theta minus tan square theta is equal to 1. That is the second identity. Cosecant square theta minus cot square theta is equal to 1. That is the third square identity. Quotient identities, these are the simplest one. Tan theta is equal to sine by cos and cot theta is equal to cos by sine. These are generally we call it as quotient or ratio identities also. Ratio also we can call. Now multiplicative identities is a cool one. Sine theta into cosec theta is equal to 1 and tan theta into cot theta is equal to 1. Sec theta into cosec theta is equal to 1. These are the multiplicative square identities. See here, everywhere we got 1, 1, 1, 1, 1, 1. These are the used. We generally use this, but these are the things we generally convert trigonometry into numbers. Now let's go there. Use these formulas there and get converted or simplified is as small as possible. Let's go on. Given. Okay, let's start at the given question. Sec theta into 1 minus sine theta into secant theta plus tan theta. This is the given question for us. Okay, so when we are planning to get the square identities, let's do one thing. Let's take this one inside. Instead of making three brackets, combine few brackets. Let's combine that. Now what I am doing, the secant I am taking it once and again I am taking it twice. I am distributing that. Secant theta into 1, obviously it's secant theta minus secant theta into sine theta. It's nothing but secant theta into sine theta. This is the first one. When we have multiplied, obviously don't forget this. This is in the form of secant theta plus tan theta. Right? I think you are able to understand. When I am planning to make smaller, instead of two things I distributed inside, I made it into two brackets. Okay, cool. Now if you see, are we approaching any formula here? Are we approaching any square identity or multiplicative identity? Please remember, I am telling a logic to you. That is, whenever we are planning to convert, this is the logic what I am giving. Whenever right, we like to convert, right, convert general number into square, general power, right, general power into square power. There is a formula which can help it out. That is, this is what. So, a plus b into a minus b is equal to a square minus b square. Cool, see here. Do you have any square powers here? No. But using this formula, we are converting back into square. So, there is an option for us to use either this formula as this formula. Why? Because a square minus b square, that is secant square, a square minus b square, or a square minus b square. But please remember, as the sum is dealing in terms of secants and tans, there is much probability for us to use this formula. This is the formula what we are going to highlight here. But because the question is in terms of secant and tan, so secant square theta minus tan square theta is equal to 1. But there are no powers here. But just now I said, to get back to the powers, this is the formula which helps us. A plus b into a minus b is equal to a square minus b square. Means if the situation, if the question is in terms of this, we can convert as a square minus b square, so that I can use the formula whichever is related. Here in this question, everything is in terms of secant and tan. There is much possibility of using secant square theta minus tan square theta, which is nothing but 1, which is the smallest simplified form. Now think in that way. Now let's go back to the question and let's frame a plus b into a minus b there. If you think this as a plus b, okay, secant as a and tan as b, here already our a is present and minus is also present there. If you check it out, if you want it as a plus b into a minus b, a plus b and a minus, why? Because secant is a, here also secant is there. But what is b here? Tan. But do we have tan here? No man, we don't have tan. But how does tan look like? We know tan looks like this. Tan theta is nothing but sin theta by cos theta. That's what I said. We use this. How does the tan look like? Tan is nothing but sin theta by cos theta. So what do you have? We have sin. We don't have cos. Instead of cos, what do you have? Secant. Do you have secant in cos? Yes. Can't I convert? Let me go back to the question. I'm writing sec theta as similar minus, I want to write secant as cos theta, 1 by cos theta, of course, into sin theta is already there. Now let's go back to this one. Let's change that. It's nothing but obviously we have secant theta plus tan theta. Okay, now see, we are stepping forward, we are reaching. If this is a plus b, if you want this one as b, that is nothing but tan. If you check it out, we have converted secant as 1 by cos. Why? Because you can write the formula since, right, we know cos theta into secant theta. That's what I said. Cos theta into secant theta. Right. Okay. Sin into cosecant. Right. Sin into secant theta is equal to 1. Sin into cosecant. Yeah, I think I messed up here. It's nothing but cos theta into secant theta is equal to 1. That is the formula here. So cos theta into secant theta is equal to 1 means in the place of secant, 1 by, we can write it as 1 by cos. Now let us check it out. Can I convert this as secant theta minus sin by cos? I like to write it as sin by cos. Of course, we are having this one. What is that one? Secant theta plus tan theta. Right? Now, as we thought, sin by cos, just now we said sin by cos is nothing but tan theta. In the place of that, I am writing secant theta minus tan theta into, however, we are having here secant theta plus tan theta. Right? Let's make this one as separate for you. Now, is it looking like a minus b into a plus b? Yes, obviously. Then it becomes as a square minus b square, which is nothing but secant theta and this is tan theta. So which is nothing but secant square theta minus tan square theta. Just now I said secant square theta minus tan square theta is nothing but what? 1. So we are using the square identity. It's logical stuff. In simple, remember, simplifying means as making as small as possible, and numbers are the smallest. Using identities, we can convert reg into numbers. So, right, how can we use? By using the square identities and multiplicative identity, but of course by using the quotient identities, which helps us to convert general number into square identity. Hope you are able to understand. It's a tricky way, but this is how we are supposed to think on while dealing. Let us deal with one more sum under the simplification using the same logics which I have said just now. Okay, so simplify. Simplify means making as small as possible, and numbers are the one which make the question as small as possible. And from trigonometry to the numbers, it is nothing but using square identity. Just now I have revised you. Now, if we are able to see the square here, so obviously we should get an idea by you seeing the word cot square here. Get an idea that we are going to use, as I said you just now, it's nothing but square identity 3. Square identity 3. What's the square identity 3? Cosecant square theta minus cot square theta is equal to 1, which is nothing but, or the corollary of that, cosecant is equal to 1 plus cot square theta. This is what we are supposed to use. Means wherever you find 1 plus cot square, we are supposed to keep what's there, cosecant square theta. Let's go from here. So it's nothing but 1 minus cos theta into 1 plus cos theta into, just now I said, it is nothing but cosecant square theta. Yes, okay. Now again, just now I recall you, right? If there are no squares, there is one formula, a minus b into a plus b, which converts it as a square minus b square. Now, is it looking like a minus b into a plus b? Obviously, it is looking. Now, convert this one as a square minus b square. Of course, don't forget this cosecant square theta. Okay. Now, here, if you take this as the first step, right, here is nothing but 1 and b is nothing but cos theta, right? Now, it is looking like 1 minus cos square theta into, obviously, the other one, cosecant square theta. Okay, again you are able to see the square there, or just now I recalled, as we are using the square identity 3 here, we are having square identity 1. What's the square identity? Sin square theta plus cos square theta is equal to 1, which is nothing but, if you see that, sin, which implies sin square theta is equal to 1 minus cos square theta. Just now I record, means wherever you find 1 minus cos square theta, you write it down as sin square theta. And here what do you have? Cosecant square theta. Now everything is in terms of square, but what do you have here? Multiplication, means it is indicating that we are using multiplicative identities. Now let's get back to multiplicative identity, right? If 1, what is the multiplicative identity 1? Sin theta into cosecant theta is equal to 1. 1 is into is there, so into is there means obviously we have to go for multiplicative identity. Now I am converting this one as whole square, and it is nothing but sin theta into cosecant theta. So sin theta into cosecant theta is equal to how much? It's 1. So 1 whole square is nothing but 1. So we have simplified. So just a tricky thing, just a trick, right? He's asking us to simplify. Make as small possible. Square identities are the one which convert trigonometry into numbers. Why? Because numbers are the smallest. Now, as we have 1 plus cot square, 1 plus cot square, we have converted as cosecant square, 0.1, and it is in the form of a minus b into a plus b. A minus b into a plus b means a square minus b square. That is 1 square minus cos square, which is nothing but sin square. 1 minus cos square is nothing but sin square. Again, we are having squares. Of course, the main thing is into multiplication. We are using multiplicative identity 1, that is sin theta into cosecant theta is equal to 1. Of course, whole square sin into cosecant 1, we have simplified. Hope you got it. In this channel, I have been placing both math and science videos.